Okay, in the last video I explained to you how capacitors were a storage tank for electricity. Now I'm going to explain to you how we can control the rate at which we store and discharge the electricity for a capacitor. And it's real simple. It's by an RC circuit, which stands for resistor and capacitor, and it equals this little funny symbol here. This is the way I write it, which is tau, which is the Greek letter for T, and that stands for time constant. What that means is you have a graph here. This would be the voltage, and this is our time constant. So we have T1, T2, T3, T4, and T5. And what they're saying is after T5, the capacitor will be pretty much fully charged. You'll never get 100%, but you'll get it very, very close to 100%. Okay, so the way this works is it's R times C. So it's resistor times capacitance. So if you have a 1 ohm resistor, and let's say you have a 1 farad capacitor, it would take 1 second right here under T1 to reach 63.2% of its charge. So on a graph, if you're at, let's say this is 50% of the voltage, 100% of the voltage, 0%. So under 1 second, we would be at 63.2% of the full charge of the voltage of this capacitor. Alright, to get to T2, it would be 63.2% of what is left of it. To get to T3 would be 63.2% of what is left of that. And then so forth until you get to T5, which would pretty much be very close to 100%. So the capacitor would be 100% charged up. So if you had, let's say we had a resistor that was a 2 ohm resistor, and you had a 1 farad capacitor, then you would times that, so it would be 2 seconds. It would take 2 seconds to get to 63.2% of this capacitor's full capacity. And the reason why that works is picture blowing up a balloon. And I told you this is like a storage tank. So picture it being air and you're blowing up a balloon. And if you blow up a balloon and you put 5 psi of pressure in it, and you stop blowing it up, and then you were going to blow into it again, you would have to blow harder than 5 psi because you have 5 psi coming back at you. So you would have to blow greater than 5 psi to have the balloon to inflate. And as you blow into it, the amount of pressure you put into it, that amount of pressure is coming back at you. So you're going to have to increase the pressure to get the balloon to inflate even further. So a capacitor works the same way. Alright, now a capacitor actually discharges on the inverse. So as this graph increases this way, well, then it would decrease the same way. So the first T1 would come down and it would discharge at 63.2% and so forth. And then the current is the inverse of this, which means that it is charging at a slower rate, which is 60, whoops, I'm sorry. Let me do the quick math in my head. 36.8%. So it'll be 36.8% and then so forth as it charges. And then as it discharges, the current would be the inverse of that. Alright, one of the ways we use a capacitor is for smoothing a wave out. So let's say you have a pipe and you're sending 10 psi down this pipe, and then you had another tank that had air pressure in it, and this would be the capacitor. And let's say there was 10 psi in this. Well, let's say your compressor dipped down and you were only getting 8 psi out of it. Well, this capacitor would would allow 2 psi of airflow out of here, so you wouldn't lose air pressure. So that's the way we use smoothing capacitor. If you have any questions on charge and discharge time of capacitors, leave a comment below and I can elaborate. It's not really as complicated as a lot of sites make it out to be. There's online calculators. You can put your parameters in and it will tell you your times of capacitance, charge and discharge. Okay, as you can see here, I am using the DSO 138. Which to show you this is a useful oscilloscope. I do have times 10 probe on it. It's not the probe that comes with it. This is 24 volt AC that's coming in, and then I'm going to switch it over and rectify it. Alright, now you can see that voltage is rectified. Okay, the problem is we're wanting a smooth DC line across here, and as you can see, we're having dips. So what we're going to do is, let me get the glare out of it. What we're going to do is we're going to put a capacitor in it to smooth it out. Okay, now let's hook our capacitor up to it. And it smooths it out. So what it's doing is it's adding pressure where the dips are. So where there is a dip in voltage, there is pressure being added to it to smooth the dip out. Well, I hope you learned something from this, and if you have any questions, drop a comment below. And give me the thumbs up and like and subscribe. And y'all have a good day.